Another place you can store potential energy is in a spring. The potential energy stored in a spring is 1/2 kx squared. What are all these things? Well, k is the spring constant, and x is the distance you've deformed the spring. So if the spring is just sitting here and it's like this when it's just sitting still, you haven't deformed it at all. X is not the length of the spring. When you stretch it out a little bit, that is the length x that we're after. The amount you've stretched the spring from rest or compressed it from rest. So if you go back this way, that distance is x. Now, what is k, the spring constant? That's a property of the spring that has to be measured or given to you in some way. So what are the units? Well, on one side we have joules. On the other side, we have the spring constant k, and we have this distance x, and that's going to be meters squared. So the units in our unit analysis are joules per meter squared. Well, a joule, I'm sure you all remember by now, a joule is a Newton times a meter. So this ends up being a Newton per meter. The spring constant tells us how much force it takes to stretch the spring by 1 meter. That's what the spring constant tells us. And within small deformations, it's a linear thing. We'll get to at some point in lab or talk about nonlinear effects, but mostly it's linear. And that's it for potential energy in a spring.